Good morning, algebra students. Today we're going to be covering the Unit 3. We're actually going to be going over the guided practice in this video. So if you guys just follow along and write down everything I write and do everything I do and listen to everything I say, it'll all make sense, at least I hope. And at least it'll make a lot more sense than it did before. And you'll be able to get through it relatively quickly and relatively painlessly. All right, so let's go ahead and get to it. And so go ahead and open your packet up to the first page where the guided practice starts. You'll see this problem here. So if you're not there already, go ahead and turn to this problem. And what we're going to do is just kind of go through each of the problems and read them and talk about them and work them all out. Here it says Robert is 5 years older than his brother Evan. Together their ages add up to 67. How old is each brother? So we need to find Robert's age and Evan's age. We know that their ages should add up to 67. And we know Robert is 5 years older. Okay, so I want you to take a moment, pause the video, see if you can figure out what this is, what these two ages would be. Now, hopefully you're able to figure out that Robert would be 35. Yeah, 35. Well, Evan is, well, that's not right. Let's erase that. Let's just go ahead and do some algebra and figure it out. So let's see. Robert is 5 years older than his brother Evan. So let's say Evan's age is X. Okay, and this is basically how we're going to be solving these sorts of things. Then Robert, since he's 5 years older, he'll be X plus 5. Okay, so whatever Evan's age is, Robert is that age plus 5. Now, if we add their two ages together, they'll add up to 67. So if we take Evan's age, which is X, plus Robert's age, which is X plus 5, then their total should add up to 67. Okay, so that's Evan's age plus Robert's age is 67. Now, what can I do here to help me solve this? Well, I can combine these two x's. X plus X is 2X. We still have that plus 5 there. Now, to help us get X by itself, we're going to go and subtract 5 both sides of the equation. So that'll be 2X equals 62. Then divide by 2 on both sides to get X by itself. 31. Now, what does that tell us? Well, X was Evan's age, right? So X is 31. So now we know Evan is 31. And Robert is 5 years older, right? So if we did 5 years older, that's 36. And you could always double check. They should be 5 years apart. Robert, 5 years older. And that's true. And their ages should add up to 67. And they do, right? So that's how we could use algebra to solve problems like this. But don't worry about if I went a little too fast or that was really confusing, because we're going to practice this a lot. I mean, a lot. So don't worry about right now if it's like, oh, I didn't really understand that fully. We're going to be going over a lot of problems like this, and it'll become really like second nature by the end of this unit, hopefully. Okay. So a lot of times instead of X, sometimes they use N. So here, if they're saying Evan's age is N, then Robert's age would be N plus 5. So in my example, I used X. And that's very common for people to use X, but it's also very common to use N. So those are two of the more common variables for this type of problem, but you could have used any variable. You could use Y or Z or whatever, okay? Now, if we let N be Robert's age, then Evan would be 5 years younger. So if N is Robert's age, then Evan would be N minus 5. Okay, so you want to make sure you're denoting which the variable corresponds to which person's age, or the variable corresponds to what. You know, that's very important. Okay. Here that says the ages of them were 67. Okay. Now, let's see if we could solve for x in this following one. Well, basically what they're asking here is something plus 5 equals 10. So some value x plus 5 equals 10. So what would be the value of x here? What plus 5 gives me 10? Well, hopefully you can see that, oh, x would have to be 5, right? Because 5 plus 5 is 10. So x has to be 5. So x is 5. But you could also solve it by subtracting 5 from both sides of the equation. And that's what I want to kind of get you in the habit of is in order to get x by itself, we're going to have to get rid of this plus 5. The way we do that is subtracting 5 from both sides of the equation. That will cancel this 5, but that'll leave you with x over here, x on the left, and then on the right side, 10 minus 5, which is, of course, 5. So you could always do this sort of thing, but also you should be able to figure it out from just kind of looking at it. Now, it won't be easy to figure. This one was an easy one, but some of them get much harder, and you're going to need to learn how to like subtract from both sides of the equation, or we might have to add to both sides of the equation. Sometimes we'll have to divide on both sides of the equation. It just depends on what the situation is. Okay, let's go ahead and solve this one. So if I subtract 87 from both sides of the equation, this will give me x by itself. So if I subtract 87 here, I have to subtract 87 here on both sides of the equal sign. Make sure it's on both sides of the equal sign. So equals, and this is 5 again, right? Kind of the key here is that whatever you add to one side, you add to the other, right? Because let's take any true mathematical statement, right? So think of any true mathematical statement. Maybe I'm going to say 2 plus 3 equals 5, right? This is true, right? Now, if I add something to the left side, I would have to add it to the right side, right? So wherever the equal sign is, whatever you add to one side of that equal sign, you have to add to the other, right? Because if I add, let's say I add another 4 on this side, now are these equal? Well, no. But if I add 4 on both sides, then it'll remain equal, right? It'd be 9 on both sides in this case. So whatever you add or subtract to one side, you have to add or subtract on the other side. Same thing with multiplying and dividing. Whatever I multiply on one side, I have to multiply on the other. Whatever I divide on one side, I have to divide on the other, okay? So here's an example where we're gonna need to divide here. So here it says 4y equals 32. Now, just a reminder, when you see that a number right up against the variable, in this case, the 4 is right up against the y, that means those are multiplied. So that means 4 times y equals 32. So 4 times something, some value, equals 32. So what would be the value here? 4 times what gives me 32? Okay, hopefully you know that that's 8, right? Because 4 times 8 is 32, right? So is there a way I could solve this? Well, someone might be like, well, maybe we subtract 4 both sides, but that actually doesn't work here. What you'd have to do is actually divide by 4 both sides. So since it's multiplying here, 4 times y, in order to cancel that, you need to divide by that 4. So whatever the operation is that's happening here, in this case, multiplication, you have to do the opposite. So we're going to divide. So divide by 4 both sides. That'll cancel the 4 on the left, and that'll leave you with 8 on the right. So that gives us the same answer, right? Okay. So what here just talks about what operation is the opposite of multiplication. So we want division. Okay. Division is opposite. And you can see with the 4y equals 32, divide by 4 both sides, you get y equals 8. That's great. Let's go ahead and work on this problem here. So here we have 3 times n, so 3 times something, plus 10 equals 46. Now, how would I solve this one? Well, let me just rewrite it over here. 3n plus 10 equals 46. Now, if I'm trying to get n by itself, right, I'm trying to get it where it says, my goal would be to say n equals, and then some number over here, right, some number. Maybe it's n equals, I don't know what this could be yet. But I need to get n by itself. the first thing you want to do is always get rid of everything. You want to get rid of everything on n's side of the equal sign. So on n's side, there's a 3 and there's a plus 10, right? So we need to get rid of those things. But it's important that you want to get rid of whatever's adding or subtracting first. So here we're going to get rid of that plus 10 first. So the way we get rid of plus 10 is we subtract 10 on both sides of the equal sign. So whatever you do on one side, you have to do on the other side of the equal sign. So that'll leave us with 3n on the left equals 36 on the right. Dividing by 3 on both sides to cancel out the multiplication. And that'll give you that n equals 12. Pretty easy. And you could always double check, right? 3 times 12 plus 10, well, that'll give you 46, won't it? 3 times 12 is 36, plus 10 is 46. So you could always double check by plugging in that answer back into the equation. Okay. Should we subtract 10 from both sides first or divide by 3 first? Subtract first. Subtract 10. Usually generally you want to get rid of whatever's adding or subtracting first and then get rid of the whatever's multiplying second. Okay. So I want you to go ahead and try this one on your own. Okay. So what would I do first? Right. First step is to subtract blank from both sides. Okay, then go ahead and do that. Second step would be divide by blank on both sides. Go ahead and do that. And then tell me what W equals. Okay. I'll go ahead and give you the answer. This would be W equals 10. But I want you to go ahead and figure out this and show the work. Okay, let's do this one together. So for this one, what would I do first? Well, hopefully you see I would add 20 both sides to the equation. So you get rid of whatever's adding or subtracting first. In this case, it says subtract 20. So we're going to get rid of that by adding 20, and that cancels, right? Addition and subtraction cancel each other. But if I add 20 on the left, I have to add 20 on the right as well. So that'll give us 3x on the left equals 120. Then to get x by itself, what do? Well, we divide by 3 on both sides, right? Because 3x means those are multiplying. So we divide to cancel it. That'll give us x equals, and then 120 divided by 3 is 40. So x equals 40. Okay. Now take a look at this one. Here, it has the variable on the right side. We haven't seen any like that. But honestly, it's the same thing. Whether we put the variable on the right or on the left, it doesn't matter. That does not change the problem at all. In fact, if you wanted to, you could always rewrite it by putting it on the left if you want. But you don't have to do that, okay? You don't have to do that. Let's go ahead and keep it on the right side. I want you to get in the hang of being able to do it whether the variable's on the right or the left. Right? So here I'm trying to get y by itself. So I'm going to go get rid of this 5 first. I'm going to subtract 5 both sides. Again, you don't want to get rid of this 6 yet because the 6 is being multiplied here. Okay? You get rid of that last. All right, so subtract 5 both sides. This cancels. 41 minus 5. Well, what's that? That's 36. Okay. On the right side, we have 6y. To get y by itself, we're going to go ahead and divide by 6, both sides of the equation. That'll give us that 6, right? 36 divided by 6 is 6 equals, and then these cancel, so just y over here. So 6 equals y. Okay, that's the same as saying y equals 6, 6 equals y, same thing. Okay, so again, it doesn't matter which side of the equation it's on. Why don't you go ahead and try this one on your own. Okay, so what would be the first step? See if you can figure that out, and then go ahead and solve it from there. Okay, now this one's got a little more going on, right? Notice on the left side of the equation, we have a 3x plus 5 plus 4x. So we got 3 terms over here on the left, And then on the right, we have 52 plus 2. Now, what I want you to see is that on the left side, we could actually combine some things together. Now, you can only combine things when there are like terms. So they're same type of term. So for example, the 3x cannot combine with this 5 because the 5 doesn't have an x. But the 3x and the 4x, these can combine together because they're like terms. Now, you only want to combine like terms on each side of the equation, right? So these are all on the left side, so we can combine these together. Whereas these are on the right side over here, we'll combine these together. So if they have the same variable, you can combine those. Also, if they don't have a variable attached, like this 52 plus 2, they're both on this right side, and they're both just constant numbers, so we can combine those together as well. So let's go ahead and rewrite it, combining like terms on the left. So 3x plus 4x, we can combine those, and that would be 7x. There's still a plus 5 over here on the left. So all I did was rewrite this left side by combining the 3x and 4x. Now this right side, we can combine this 52 plus 2, right? They're both just numbers. So that's going to be 54. From here, what would we do next to solve for x? Well, we would subtract 5, both sides of the equation. That'll leave us with 7x on the left equals 49 on the right. Divide both sides by 7 to get x by itself. These 7's cancel. So I'll leave it with x equals, and then 49 divided by 7 is 7. So x equals 7 in this case. And you can see all the work that they do here. Get the same answer here. All right, let's go ahead and give this one a try as well. What can we combine over here on the left? Well, hopefully you can see I can combine the 2x and the 3x. So let's go ahead and combine those. That'll make 5x. Now on this side, we still have a plus 6 over here, so that gets included as well, but we cannot combine with the x's. On the right side, we can combine the 45 and 16. They're both just constant numbers, so we can combine those together. So that'll be, what, 61? Okay. What would be my next step? Hopefully you'd see I could subtract 6 both sides of the equation. That cancels out this. On the left, we still have 5x. And on the right, 61 minus 6 is 55. Divide by 5 both sides of the equation to get x by itself. That'll give us x equals 11. Just like that. Okay. Let's go ahead and look at this next problem here. It says 5y plus 2 equals 3y minus 10. Now, this one's a little bit different than anything we've seen so far. Notice on this one, the y is on both sides of the equation. There's 5y on the left, and then there's 3y on the right. So here in this case, if we have y's on both sides, we generally don't like that. If we have variables on different sides, we don't like that. We want all of that variable together. Okay, so when we're solving for y in this case, we want all of our y's together. So how do we do that? Well, what I could do here is I can go ahead and subtract 3y both sides. Okay, so you could also subtract things with the variable as well. So I'm going to go ahead and subtract 3y on the right. That way it'll cancel. And I'm going to go ahead and whatever you do to one side, you have to do to the other. So since we subtracted 3y here, I have to subtract 3y on the other side. So now I can combine these. 5y minus 3y, that's 2y. And there's still a plus 2 over here. And then on the right side, there's a negative 10. So equals negative 10. Okay, that minus 10 is the same as saying negative 10. So making sure that negative still sticks around. Okay, what would be my next step to solve for y now? So now it's like what we've seen before, right? We would just subtract 2 both sides. Now careful, negative 10 minus 2, that's actually negative 12. So we'll have 2y on the left equals negative 12. Then divide both sides by 2 to get y by itself. Y equals -6, right? Negative divided by positive is negative. Okay, so that'll be your answer. And again, you could always plug it back in to make sure it works. You can plug it back into the original equation and make sure it works. Make sure you get an equal statement. And you can see they got the same answer. Okay. Hopefully that makes sense. I want you to go ahead and give this one a try on your own. I'll give you a hint. The first step will be subtract 2x both sides of the equation. Okay. And then see if you can finish the rest of that on your own. Okay, let's take a look at this one right here. Here we have 3 and then parentheses x plus 5 parentheses equals 42. So here we have a 3 up against a parentheses. So whenever you see a number or really anything right up against a parentheses, that means those two things are multiplied. So this is the same as saying 3 times x plus 5. So it's 3 times that whole thing in the parentheses. So how do we do something like that? Well, hopefully you've seen this before, but if not, that's okay. What happens is this 3 gets distributed to everything in the parentheses. Distributed means like passed out, right? If I say like, oh, someone's distributing flyers, they're distributing it, they're passing it out, right? So what happens is this 3 gets distributed to every term in here. Okay, so the 3 gets multiplied by x, and the 3 also gets multiplied by the 5. So that's what it means. This is like the distributive property. Hopefully you've heard that before. But if not, don't worry about it. Anyway, the 3 gets multiplied with everything in the parentheses. So 3 times x, well, we'll just write that as 3x. Right? Doesn't that mean 3 times x? Yeah. And then 3 times 5, that's 15. So that 3 gets multiplied with the x and also with the 5, and that gives us this. Then equals 42. Now the 3 does not get distributed to anything outside the parentheses. So only to the stuff in the parentheses. So it doesn't get distributed to the 42. Okay. Subtract 15 both sides. 3x is left, this cancels. 3x equals, and then what's 42 minus 15? 27. So 3x equals 27. Divide both sides by 3 to get x by itself. That'll give us that x equals 9. And there you go. This one's kind of the same deal. Here, the 2 is going to get distributed to the 3x and also to this minus 4. So 2 times 3x, that's 6x. And then 2 times minus 4 is minus 8. This minus is the same thing as a negative, right? So a positive times a negative is still negative. Okay. Here we would add 8 to both sides to start. Again, you get rid of whatever's adding or subtracting first. That'll leave you with 6x equals, and then 28 plus 8 is 36. Divide by 6 both sides of the equation in order to get x by itself. X equals 6. Okay, 36 divided by 6 is 6. Now this one is going to incorporate a lot of what we already covered, a lot of different topics. So, but the first thing we want to do is distribute. On the left side of the equation, the 4 is going to get distributed to the n plus 6. And on the right side, the 2 gets distributed to both the terms over here, the n plus 5. So let's go ahead and rewrite this equation after the distribution. So 4 times n is 4n, plus 4 times 6 is 24, equals, and now let's distribute on the right side. 2 times n is 2n, plus 2 times 5 is 10. Okay, hopefully that made sense. Next, Notice we have n's on both sides of the equation. Now, generally, we don't like that. So we're going to go ahead and subtract 2n on the right side. That way, we'll only have n's on the left side. So since we subtracted 2n on the right to cancel, you have to subtract 2n on the left. Whatever you do on one side of the equal sign, you have to do on the other side of the equal sign. 4n minus 2n is 2n. All right, 4 minus 2 is 2. Plus 24 equals, and then what's still over here on the right? It's a 10, isn't it? Okay. Subtracting 24 from both sides to help us get n by itself. That'll give us 2n on the left equals 10 minus 24. Now keep in mind, here, whenever you're working with positives and negatives, remember, you keep the sign of whatever you have more of whenever you're adding or subtracting. So here you have more negatives, don't you? Right? 10 and then negative 24. So that's going to be negative 14. Divide by 2 on both sides of the equation, and then we'll have n by itself. So n will equal, a negative divided by positive is negative 7. So in this case, negative 7. Okay. Cool. Now, they might just continually just throw more things at you, right? So for example, in this one, here we have 3 plus 5 times 2x plus 4 equals negative 7. So they're just throwing more stuff at you. Now, in this case, what should I do first? Should I add the 3 and the 5? Or should I distribute the 5 first? Well, generally, you want to distribute that. You want to distribute first, okay? Don't add first. Do not do that. The reason why is because hopefully you remember your order of operations. Remember, you do like parentheses, then exponents, then you need to do stuff in the parentheses, then exponents, then multiplication and division, then adding and subtracting. So we need to do the multiplication, which is this distribution. Is multiplication. So we need to do the multiplication before you add, okay? So in this case, we're going to go and distribute this 5. Actually, this is the same problem down here. Let's work on it down here. So 5, this gets distributed here. So on the left side, we still have this 3 plus, and then 5 times 2x is 10x. And then 5 times 4 is 20. On the right side, nothing changes. It's just a negative 7 so far. Now on the left side, is there anything we can combine together? Are there any like terms that we can combine together on this side of the equal sign? Well, yes, we can combine this 3 and this 20. So on this left side, we'll have 10x plus, and we can combine the 20 and the 3, 23. Equals negative 7. Next thing we would do is subtract 23, both sides of the equation. So that'll give us 10x, right? Because this cancels, but you're still left with 10x equals negative 30. Divide by 10 on both sides of the equation to get x by itself. X is negative 3 in this case. Now, what about this one? Here we have a fraction. Okay. Now, they're going to show you one way to do it, but the way I'm going to show you is a little bit different. What I would say is here, they're showing you, oh, you could subtract 2 both sides. And of course, you can do that and subtract 2 both sides and solve that way. But usually when I see a fraction, I don't like fractions. I prefer that they were gone. So, and I know a lot of students feel the same way. You probably, when you see a fraction, it makes it intimidating, right? I feel the same way. I don't really like fractions. I feel like it makes it quite a bit harder sometimes. So when I see a fraction, what I want to do is I want to multiply everything by whatever the denominator of that fraction is. So in this case, since the denominator is 4, I'm going to multiply everything by 4. Okay. Now this 4 that I'm multiplying by is going to distribute to everything, right? I put the parentheses around everything, didn't I? So 4 times this 1/4 x, 4 times plus 2, and then 4 times the 7. So why would I want to do that? Well, excuse me. Well, when I do 4 times 1/4, whatever I multiply here, the thing I'm multiplying here, 4, is the same as the denominator, right? So those will just cancel. So that'll leave you with just 1x. The 4 and the 1/4, the 4 here and the 4 in the denominator, those cancel. That'll leave you with 1x. Plus 4 times 2, that's 8. And then 4 times 7 is 28. Here we just subtract 8, both sides of the equation. That'll give us 1x, by the way. 1 times x, you could just write it as x. Okay, so whenever you see 1x, you could just rewrite it as x. Or 1 times anything is that thing, right? So 1y would just be y, or 1n is just n. 1x is just x. 28 minus 8 is 20. And you're done. Okay, so the main thing here I want you to learn from this one is when you see a fraction, one way to deal with it is just to multiply everything in the equation times whatever that denominator of the fraction is. And that'll basically cancel out that fraction. Everything else gets multiplied by that as well, though. Okay. Here we already had done this one. This is 20, right? So don't need to do it again. Same problem. Okay. So what about this one? 1/3 n minus 20 equals 10. Well, what am I going to multiply everything by? Hopefully you could see I'm going to multiply everything by 3 because this denominator is a third. So I'll multiply everything by 3. When I multiply this one, that'll give me the 3's cancel. 1n is what I'm left with there, which of course I could just write it as n. And then 3 times negative 20 is negative 60 equals, and then 3 times 10 is 30. To get n by itself, we're going to add 60 both sides. That'll give us n equals 90. And you're done. Okay. Hopefully that makes sense. For this one, same thing. Let's multiply everything by that denominator. In this case, I see there's a denominator of 3, so I'm going to multiply everything by 3. Everything. Every term gets multiplied by 3. So 3 times 21 is 63 equals, then when I do 3 times this 1/3 x, the 3 cancels with this 3 in the denominator. That leaves me with 1x, which of course I could just write as x. 3 times 10 is 30 plus 3 times 2 is 6. What would be my next step from here? Well, hopefully you can see that on the right side, we can combine this 30 and this plus 6. They're both just constant numbers. You can combine those. So let's go ahead and do that. 30 plus 6 is 36. So here we'll have 63 equals x plus, combine these together, 36. To get x by itself, lastly, we would subtract 36 on both sides of the equation. That'll give us x equals 27. Okay. On the example they show, they actually combined the 10 and the 2 first before doing that. That's fine. Okay. This is just the same. They're just doing the same thing. Okay. Okay. Now, sometimes the answer is going to be a fraction. Okay. Don't worry about that. Sometimes the answer is going to be a fraction. That's just how it is. Okay. So if the answer is a fraction, that doesn't mean necessarily it's wrong. Okay. A lot of times in algebra, you're going to get a fraction answer. Don't worry about it. Okay. You might want to check your work, make sure you did it all correctly, because usually it won't be a fraction, but a lot of times it will. So if you get a fraction answer, usually I would just check my work to make sure I did everything correctly. But just because it's a fraction doesn't mean it's wrong. Okay. So here's an example of one that'll give you a fraction answer. So, but you solve it the same way. I'm going to go and subtract 5 both sides of the equation. So that'll give us 3x on the left equals, and then 12 minus 5 is 7. Divide by 3 on both sides of the equation. Here it cancels. X equals, and then on the right side, it's 7/3, right? This does not divide evenly, right? So 7 does not divide by 3 evenly. You won't get like a whole number answer. Here it's just, if you don't get a whole number answer, right, it's just a fraction, I would just leave it like that. Okay. Now, just like with any fractions, I would make sure that I would check to see if it reduces at all. In this case, it does not reduce. So 7/3, I would just leave it like that. Okay. But if if you could reduce it, I would suggest reducing it. So let's do some on our own. So here we could, to solve for x here, we would divide by 5 both sides. That'll leave us with x equals 9/5. And I would just leave it like that. It doesn't simplify and it does not divide evenly. Divide by 2 both sides for this one. That'll give us that x equals 15 halves. Okay, that's fine. Divide by 7 both sides on this one. That'll give us that x equals 10/7. Okay. They're showing over here that you could also rewrite these as mixed numbers, right? So 9/5, you could rewrite it as 1 4/5. I wouldn't worry about that. Usually, for me personally, I prefer to have my answer as a improper fraction. I don't really like 1 4/5 or 7 1/2. As you get higher in math, you'll basically never see mixed numbers like this. You would always see it as a improper fraction. So I would just get in the hang of just being okay with improper fractions. Okay. Here's some more we could do. Divide by 10 both sides. Here that x equals 3/10. Again, it doesn't simplify. It doesn't divide evenly. You would just leave it like that. Okay. See if you can do number 5 and number 6 on your own. So go ahead and pause that. They already show you the answer, but I want you to show the work as well. Okay. Go ahead and try number 1. Try number 2. For this one, let's go ahead and work on this one together. Number 3. Again, you're going to get a fraction answer, but that's okay. We're going to go divide by 50 both sides of the equation. Divide by 50. And then that'll leave us with x equals, and then 20 over 50. Well, that fraction, this one actually can be reduced, can't it, right? You could divide both top and bottom by 10. So here, this one is, you could simplify it. So we're going to divide both top and bottom by 10, and that'll give us 2/5. Hopefully you remember how to simplify fractions, but if not, that's okay. Just do your best. So 2/5 is the answer here. Okay, great. And then it also asks for these ones, is the solution x greater or less than 1 whole? Same here. Now, the way you could tell is this one's actually less than. less than 1. And the way you could tell is because the numerator is less than the denominator. Okay, so if the numerator is less than the denominator, then it's less than 1, right? So 2/5 is less than 1. Now, if the numerator is greater, then that would be greater than 1. Okay, see if you do number 5 on your own. Okay, now we're just going to work on a bunch of problems. Okay, so I'll do a couple of them, but I'm going to expect you to do most of them, a lot of them on your own. Okay, so number 1, I think you do it on your own. Number 2, go ahead and do that on your own. I'm pretty sure you can do most of these on your own. So if you want to, you could just try all of them on your own, and then the ones you're stuck on, I'll show you some of them and kind of just go through the video and watch the ones you need. Okay, so like for this one, I'll go ahead and work this one out with you because x is on the right, but it's the same thing. Go ahead and subtract 5 both sides of the equation. That'll give you 90 on the left equals, and then this cancels, so you're left with 3x. Divide by 3 on both sides of the equation to get x by itself. Again, I want to say that if the variable is on the right or on the left, it doesn't matter. 30 equals x. That's absolutely acceptable to write it that way. X equals 30 is also equally acceptable. Okay. For number 4, you would combine the 3x and 4x, right? They're both have x's and they're on the same side of the equation. So you'd combine those together. So that would be 7x plus 5. So on the left side, this becomes 7x plus 5 equals, and then 40. Okay, go ahead and solve it from there. Similarly, number 5 here, on the right side of the equation, you can combine this negative 2x and this positive 12x. You can combine those together. So that'll give us 94 equals, and then combine the negative 2x and the 12x. That'll give you 10x, and then minus 6. See if you could solve it from there. For number 6 here, notice how there's x's on both sides of the equation. We don't like that. We like having all of our x's on the same side. So since we like having all our x's on the same side, we're going to go and subtract 2x both sides of the equation. That'll cancel over here. 4x minus 2x, that's 2x. Here you'll have a minus 6 equals, and then what's left on the right side is 30. So now we only have x's on the one side, which is great. Okay, if you moved all your x's to the right, that's acceptable too. You should get the same answer regardless of move. If you moved all your x's to the left or moved all your x's to the right, you'll get the same answer as long as you don't make any mistakes. Okay, if you want to, you can do it both ways and just to make sure you get the same answer. Okay, but I want you to go ahead and finish this one up on your own. Again, all of your answers should look like x equals something. Excuse me. All right, try number 7. For number 7, the first thing you would do is add 3x to both sides. Okay, that would be your first step. Okay, I want you to see if you can finish it from there. Okay, again, your answer should be x equals something for all of these. For number 8, what's the first thing we should do? Well, the first thing we should do is actually distribute the 4, right? The 4 gets distributed to both these in the parentheses. So 4 times 2x is 8x plus 4 times 3 is 12 equals 84. Okay, I want you to try it from there. Okay, see if you can finish it up from there. Okay, and as you can see, they're just getting more and more complicated. Let's go ahead and do number 9. 3 gets distributed to both of these. So it does not get distributed to these others here. It only gets distributed to the stuff in the parentheses here. So that's going to be 9x minus 15. There's still a plus x over here and a plus 10. On the right side is just 45 by itself. Okay. Now on this side over here, on the left side, what can we combine together? Well, hopefully you could see, oh, I've got a 9x and I have a plus another x. You can think of this as a 1x, right? So 9x plus a 1x, well, that's 10x. So on this left side, we have a 10x from combining 9x plus 1x. And then we have a negative 15 plus 10. Well, that's negative 5 when we combine those. Negative 15 plus 10 is negative 5. On the right side, we have 45. Okay, hopefully that made sense up to here. I want to see if you can solve it, do the rest on your own. Okay, get it to where it says x equals something. Okay, so you'll finish it from there. Number 10, this one has a couple of distributing going on. So we'll distribute the 4 times x, 4 times 5. And also this 2 gets distributed to this x and negative 10 here. So that's 4 times x, that's 4x. Plus 4 times 5 is 20. On the right side, 2 times x is 2x. Minus 20. And then there's also a minus 6 over here in there. Now, is there anything we can combine together on the left side? No, we can't combine the 4x and the 20. But over here, we can combine this negative 20 and this negative 6. Those can combine. So we're going to go ahead and do that. They're both just constant numbers, right? So here on the left side doesn't change. 4x plus 20 equals, but on the right side, 2x minus 26, combining the minus 20 and the minus 6. Now, notice we have x's on both sides of the equation. Remember, we don't want x's on both sides. So we're going to go ahead and subtract 2x both sides. So 4x minus 2x it'll be 2x over there. There's still a plus 20 over here. Equals, and then on the right side, we have negative 26. Okay. All right, I think you could solve it from there. Go ahead and give it a try. So see if you can get it to where it says x is by itself, right? X equals. Okay. All right, for this next one, number 11, we're going to go ahead and do what first? Well, here we have a fraction with a 2 in the denominator, right? So I'm going to multiply everything by 2. What that's going to give me is, when I multiply this by 2, that's going to give me 1x, or just x. All right, this gets distributed to everything in here. 2 times 40 is 80. 2 times 45 is 90. Then to get x by itself, you just subtract 80 both sides of the equation. That'll give you x equals 10. Now, I want to emphasize that you really need to know how to do this sort of thing. This idea of solving equations, getting the variable by itself. This is like one of the most key parts of algebra, is just being able to get a particular variable by itself, eliminating everything else around it. Okay, getting it to where it says x equals, and then everything else is on the other side. Okay, that's one of the most important things you'll need to be able to do throughout this course. This will not go away. You'll be doing this basically for the rest of Algebra 1, but also through Algebra 2, also through any other math class you're going to be taking. This concept does not go away. Okay? So the better you understand this, the better everything else is going to make sense. In this one's case, we're going to multiply everything by 4. So then the reason why is because that 4 is in the denominator, right? So this 4 gets distributed to everything here. Okay, I want to see if you can finish that one on your own. Okay, let's go ahead and see if you can do that. For this one, we're going to multiply everything by 8. So 8 times this, 8 times this, 8 times this, 8 times this. Okay, so 8 times 1/8 x, the 8's cancel. That leaves us with 1x. So you could write it as 1x or just x, either way. And then 8 times -5 is -40. 8 times 2/8 x, again, the 8's cancel, so that leaves you with 2x. 8 times 25, well, that's 200. Okay, what would I do next? Well, hopefully you'd see, okay, on the left side, we can combine this 1x and this 2x, right? Those combine, don't they? Right? They are like terms, and they're on the same side of the equation. So we can go and combine those. So that's going to be 3x minus 40 equals 200. The next step, hopefully you know from here, would be to add 40 both sides of the equation. So that'll give you 3x equals, and then on the right side, it'll be 200 plus 40. That's 240. Divide by 3 on both sides of the equation to get x by itself. This cancels. X equals, and then what's this? 80, right? Okay, cool. All right. Let's go ahead and do number 14. Notice to start number 14, I noticed that, hey, there's x's on both sides of the equation. I don't like that. I want all my x's together on the same side. So I'm going to go ahead and subtract 2x over here to cancel out that. That way I'll only have x's on the left side. But if I subtract 2x here, I have to subtract 2x here. Whatever you do to one side, you have to do to the other. Okay, 4x minus 2x is 2x. So on the left side, we still have 2x plus 9. And on the right side of the equal sign, we have 14. All right, subtract 9 both sides of the equation. That'll give you 2x equals 5. And my last step to get x by itself would be to divide 2 both sides of the equation. Here we get a fraction answer, right? Because 5 does not divide by 2 evenly. So we would just leave it as a fraction. Okay, no worries. 5 halves is the value of x. 15. Notice on the left side of the equation, the left side of the equal sign, we can see there's a lot of x's, right? There's 5x plus 3x plus 2x plus 1x. And we should be able to combine all of these together because they're all like terms. They all have x, right? So 5x plus 3x, that's 8x, plus 2x, that's 10x, plus 1x, that's 11x. So over here we have 11x equals, and on the right side we just have 7. Divide by 11 both sides of the equation to get x by itself. X equals 7/11. This fraction does not simplify, and it does not divide evenly, so just leave it as is. Okay, if you're able to get through all these equations, able to solve for x on all these, then you're well on your way to having a great understanding throughout the rest of this course. Okay, so now let's talk about this problem we saw earlier, right? Remember, this is the first problem we saw. Robert is 5 years older than his brother Evan. Together, their ages add up to 67. Okay, so again, here we're saying Evan, we're going to call that n, and then Robert is 5 years older, so he's going to be n plus 5. Okay, and if we add those together, they add up to 67. So hopefully this makes sense now, right? So we have Evan's age plus Robert's age, and they add up to 67. Hopefully solving something like this is now easy, right? We would combine those two ends, right? Here the parentheses isn't really doing anything. I'm not really sure why they wrote it, but it's not necessary in this case, but whatever. So we can combine those two ends. So that's n plus n is 2n plus 5 equals 67. Go ahead and subtract 5 both sides of the equation. 2n equals 62. divide by 2 both sides of the equation. N equals 31. Now, N, again, was Evan's age, right? So Evan is N equals 31. So Evan is 31, right? Because Evan was N. Robert is 5 years older than that, so he's going to be 36. All right, remember N is Evan, right? Okay. Let's go ahead and we're going to work on quite a few problems like this, and you're going to see more and more problems where you're basically going to read a couple sentences or whatever, a piece of some information, and we're going to turn that into math. So we're going to turn that into variables and numbers. So let's take a look at this problem here. This is on top of page 19. The instructions for a fashion design project require 3 different cuts of silk. The longest piece must be twice the length of the middle-sized piece, and the shortest piece must be 10 inches shorter than the middle-sized piece. The total length of the piece of silk you are given to work with is 70 inches. How long should each of the 3 cuts of pieces be? Okay, so we know that the 3 cuts together should add up to 70 inches because that's what we have in total. And then it gives us some other information, right? It says the longest piece is twice the length of the middle-sized piece, and the shortest piece is 10 inches shorter than the middle-sized piece. Now, the one thing I want you to notice is that all of the pieces kind of talk about the middle-sized piece, right? The biggest one is, or the longest piece is twice the length of the middle, right? So middle is mentioned here. Middle-sized piece is mentioned when it talks about the longest. But also the middle-sized piece is mentioned when it talks about the shortest, right? So it says shortest piece must be 10 inches shorter. And again, it mentions that middle-sized piece. So the middle-sized piece is mentioned in relation to both the longest and the shortest. So whatever thing is mentioned often, mentioned in relation to both of those, to everything else, I mean, that's usually what you want to be your variable. Okay, so in this case, we're going to have the middle-sized piece, the middle piece, that's going to be x. Okay, so whatever thing is mentioned as a way to measure the other ones, that's going to be your x. So in this case, the middle-sized piece is our x. All right, I hope that sort of made sense. Now, it'll make more sense as we practice, as we go along. But the longest piece must be represented as, so it says here, the longest piece is twice the length of the middle-sized piece. So it's twice the length of the middle-sized piece. So if we say the middle-sized piece is x, then the longest piece must be twice as much. That's 2x, right? 2 times as much, 2 times x. Now it also says the shortest piece must be represented as, now looking back at our problem here, it says the shortest piece is 10 inches shorter than the middle. So if you take the middle size piece and you subtract 10, that'll give you the shortest. Okay, hopefully that makes sense. So now we have our 3 sides. We have the middle, which is just x. We have the longest side, which is 2x. And then we have the shortest side, which is x minus 10. And we know all 3 sides together add up to 70, right? So let's go ahead and add those together. So we have the middle piece plus the longest piece plus the smallest piece. So x minus 10, that's the smallest piece, equals 70 inches. So that's our equation. So this is the equation we're going to work with. X plus 2x plus x minus 10 equals 70. Now we want to solve those and figure out what the size of each of the 3 pieces are. Okay, so let's combine like terms on the left. So we have x plus 2x plus another x. So that's going to be 4x's over here, right? So 4x minus 10 equals 70. the next step would be to add 10 both sides of the equation to get x, help us get x alone. So over here we got 4x on the left equals 70 plus 10, that's 80. Dividing by 4 on both sides will help us get x alone. That'll give us that x equals 20. So the middle size piece, which was x, that's 20 inches. The longest piece is twice as much, so it's double whatever that is. So that's 40. And the shortest piece is if you take x and subtract 10, right? 10 shorter. So that's 20 minus 10, that's 10. Now notice all three pieces, they should add up to the total, which was 70. And indeed they do, right? 20 plus 40 plus 10 is 70 inches. Okay, hopefully that made sense. We're going to work on some more problems like that. Let's go ahead and look on to the next problem here on top of page 20. It says a large can of nuts contains only walnuts and almonds. For each 1 ounce of walnuts, there are 2 ounces of almonds. If the mixture contains a total of 18 ounces, how many ounces of each type of nut does the mixture contain? So here we're going to have, it says let the number of ounces of walnuts be represented by x. So walnuts is x, okay? So it says for every 1 ounce of walnuts, there are 2 ounces of almonds. So if x is walnuts, then almonds, there's twice as much almonds, right? Right. So for every 1 ounce of walnuts, there's 2 ounces of almonds. So there's double the amount of almonds. So if x is the amount of ounces of walnuts, then 2x would be the ounces of almonds. Together, there's a total of 18 ounces in the can, right? So if we add the walnuts plus the almonds, together they would add up to 18. Whoop. I was thinking 80 for a second. 18 ounces. So x plus 2x, let's go ahead and solve that. That's 3x when we combine those, right? Equals 18. Now, what would I do to solve for x here? Hopefully you can see I would divide by 3 both sides to get x alone. That'll give us x equals 6. Now again, x was the number of walnuts, right? Walnuts be represented by x. So x is the number of walnuts. That means the amount of almonds is double that, which is 12. Again, these should add to the total, which is 18, and indeed they do. Next problem. Together, Saturn, Jupiter, and Uranus have a total of 150 natural satellites, aka moons. Jupiter has 3 more satellites than Saturn. Uranus has 33 fewer satellites than Saturn. How many satellites does each planet have? Okay. So notice that we have 3 planets here, right? Saturn, Jupiter, Uranus. But notice how they give us that information. They tell us that Jupiter has 3 more satellites than Saturn. So notice they're relating Jupiter to Saturn. And then it says Uranus has 33 fewer satellites than Saturn. Notice Saturn is used as a way to talk about both of them, right? Saturn is talked about with Jupiter, but then also Saturn is talked about with Uranus. So that's why we're going to let Saturn be the variable x. Okay, so Saturn is x because remember it's mentioned for both, right? So what about for Jupiter? So if Saturn is x, it says Jupiter has 3 more than Saturn. So Jupiter must have 3 more than that. So if we take the amount that Saturn has and you add 3 more, that'll be the amount that Jupiter has. Then it says Uranus has 33 fewer than Saturn. So if you take the amount of that Saturn has, Uranus has 33 fewer. So the amount that Uranus has is x minus 33. And in total, the 3 planets will have a total of 150 moons, right? So the amount that Saturn has plus the amount that Jupiter has, x plus 3, plus the amount that Uranus has, x minus 33, should equal a grand total of 150. So let's go ahead and solve that. So here you might see, okay, I've got x plus another x plus another x. So that's going to be 1x plus 1x plus 1x. That's a total of 3x. Those three like terms, they can combine. That's 3x. We can also combine this plus 3 with this minus 33, right? Because they're both just constant numbers. So that's going to be minus 30 when you combine those. 150 on the right. Okay, again, we're just combining like terms on the left. Now we're going to do our balancing to get x by itself. So we're going to add 30 both sides of the equation. That'll give us 3x on the left, right, after this cancels. 180 on the right. Divide both sides by 3 to get x by itself. That'll give us x equals 60. So x equals 60, which of course, x was the first Saturn, wasn't it? So the number of Saturn's actual number of satellites is 60. Jupiter had 3 more than that, right? So Jupiter is going to have 63. And Uranus had 33 fewer than Saturn, right? So 60 minus 33, that's going to give you 27. And again, you could always check, because if you add these together, it should add up to 150. Because remember, in total, they had 150 together. And indeed, they do. So that's why you could always quickly check is your answers. The answers for all these should add up to whatever the total was. Okay. Here's the next one. Go ahead and follow along as I read out loud. In 2003, the Toyota Camry was the top-selling passenger vehicle in the United States, followed by the Honda Accord. There were 35,000 fewer Honda Accords than Toyota Camrys sold in the U.S. in 2003. The total sales of the two models together equaled 833,000 that year. How many of each make of car was sold? So it says there were 35,000 fewer Honda Accords than Toyota Camrys. So Toyota Camrys we're going to call N. Okay, that's what it says. Toyota Camrys we're going to call N. So the Honda Accords would be 35,000 fewer. So for the Honda, it was, you take the number of the Toyotas minus the 35,000, because Honda had 35,000 fewer than the Toyota. So if the number of Toyota Camrys was N, and we add in the number of Honda Accords, which is N minus 35,000, then if you add those two amounts, that'll give you the total that were sold, which in this case was 833,000. Okay, I know these numbers are bigger, but there's really no difference to how you solve them. So again, on the left, can we combine anything together? Well, yes, we can combine this N plus N, that's 2N. We have a minus 35,000 equals, and then on the right side, we still have 833,000. To help us get N by itself, we're going to add 35,000 both sides of the equation. Okay, I hope you're following along, and I hope you're writing down everything that I'm writing. 2N over here on the left, and 868,000 over here on the right. Lastly, to get N by itself, we're going to go ahead and divide by 2. Divide by 2. That'll give us that N equals 434,000. And remember, N was the number of Toyota Camrys. So the number of Toyota Camrys is going to be 434,000. The Honda Accords, well, that was 33,000 fewer, right? I think that's right. 35,000 fewer. So that's 399,000. Again, if you add these together, they should add up to 833,000. Okay. Now we're going to talk about inequalities. What I want you to really notice or kind of have in your head is the difference between greater than and less than. So less than looks like this. So this is less than, and this is greater than. Okay, I know it's very easy to mix up these symbols, but a couple of ways you can kind of remember is that the mouth always eats the bigger one, right? So if I have, let's say I'm comparing 2 and 5, which way should it go? Well, it should go like this, right? Notice this, you can think of this as an alligator's mouth, right? Or a crocodile, and it eats the bigger one, right? The crocodile's more interested in eating the bigger one, right? So that's a less than in this case. So 2 is less than 5. Another way to think about it is like, to me, that looks like an L. That was kind of like a capital L. That was just kind of turned to its side. And L is for less than, right? So it looks like a squished L. L is for less than. And then the other one is greater than. Okay. So here we're going to work on these and put in greater than or less than for these. All right. So over here we have 1/2 plus 1/2. Well, that's 1, right? Right. Half of a dollar plus half of a dollar is $1. And then 1/2 times 1/2, hopefully you remember from the previous units, is that when you multiply fractions, you multiply top times top and bottom times the bottom. So which one's greater, 1 or 1/4? Well, 1 is greater than 1/4. Notice the alligator wants to eat the bigger one. And yes, 1 is bigger than 1/4. Okay, what about for number 2? On this side, 1/4 times 1/4. Again, to multiply fractions, you multiply top times top, bottom times the bottom. So this is 1/16. On the right, again, to multiply fractions, we multiply the tops. 1 times 1 times 1 is 1. And then 4 times 4 times 4, well, 4 times 4 is 16. 16 times 4 is 64. So which one's greater, 1/16 or 1/64? 1/16 is greater. Yes, 1/16 is greater than 1 out of 64. Okay. I know that's a little bit tricky because you're probably thinking, well, this denominator is more, right? But that's actually why this one is smaller. Think about it this way. Would you rather share something amongst 16 people or share amongst 64 people? Well, if you share amongst 16, you get a bigger piece, right? Right. Imagine you had like, I don't know, a cake. Would you rather share your cake amongst 16 people or 64 people, right? If you share amongst 16, you certainly have a bigger piece, right? Over here, 10 to the power of 5 times 10 to the power of 2. Hopefully you remember when you're multiplying these, as long as they have the same base here, you would add those powers. So that's 10 to the power of 7. Over here, which 10 to the power of 7 is 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that's going to be, put some commas here, 10 million. Okay, so 10 to the 7th, which is 10 million. Over here, this would be 1, 2, 3, 4, 5, 10 to the 5th plus 1, 2, 3, 1,000. That's 10 to the 3rd. So what would that be? That would be 1, 0, 1, 0, 0, 0 if you add these together. So this one is 101,000. Well, 10,000 is clearly bigger than 101,000, which makes sense, right? If I multiply two numbers together, like two very large numbers together, that would be more than this case, right? Here we're adding, it's not gonna be as big. Okay, 10% of 500. Hopefully you remember how to find a percentage of a number like this. Basically, you could change it to a decimal by moving it over twice. So that's going to be 0.10 and then times 500. Okay, hopefully you know that that gives you 50. Okay, if not, you can use a calculator. 20% of 200, you move this over twice, that's 0.20. Always move the percentage over twice when finding a percentage, times 200, and that'll give you 40. Okay, so which one's greater? 50 is greater than 40. 20% of 5,000, again, that's change it to a decimal, move it over twice, so that's 0.20 times 5,000. Which is what? 0.2 times 5,000 is 1,000. Okay, I should have known that. So this is 1,000. Here, move it over twice. That's 0.10 times 11,000, which gives you 1,100. Okay, so 1,000, 1,100. 1,000 is less than 1,100. Here, 0.001 versus 0.01. Well, this one's greater. Okay, so this is less than that. This is 1/1000th. This is 1/100th. In fact, this one's 10 times greater than that. Okay, 5%, if I change that to a decimal, that's 0.05. So what's greater, 0.05 or 0.06? Well, 0.05 is less than 0.06. Here, if we divide by this division, we can cancel out the zeros here. You're allowed to do that with zeros at the end when dividing. So 200 over 1, which is 200. Here, we can cancel out 5 of these zeros. So this would be 20 over 1, which is 20. So 200 is greater than 20. Here, if we multiply by 10, that moves the decimal over once to the right. So 0.251 times 10 is 2.51. And this one, if I divide by 100, that moves the decimal twice to the left. Here we're dividing, so we're going to move it to the left. So that's going to be moving over twice for the 100, so 0.251. So 2.51 is greater than 0.251. Okay. The number of seconds in 5 minutes, so 5 times 60, that'll give you, there's 300 seconds in 5 minutes, which is, of course, greater than 250. Now, you're allowed to solve inequalities. A lot of times we'll have an inequality that has a variable in it. And again, you can solve for that variable similarly to how we've done with equations. So here we have 3n is greater than 15. So the way you would solve that is to get n by itself, we would divide by 3 both sides of the equation. So hopefully that's not surprising. That'll cancel that. So n will have to be greater than 5. So our answer is n is greater than 5. And hopefully that makes sense. And you could always, again, check your answer. Let's pick a number that's greater than 5. Okay, you could pick 6. And indeed, if you plug in 6 here, it'll come out to a true statement, right? 3 times 6 is 18, and 18 is greater than 15, right? And if you pick any number that's greater than 5, it'll also work, right? If you pick 10, for example, right? 10 is greater than 5. So 3 times 10, that's 30, and 30 is greater than 15. So that works. You can solve these in the same way you would solve with equations. whatever you do to one side, you do to the other, and you want to cancel stuff to get your variable, your n in this case, by itself. So here we would subtract 7 both sides. That would be your first step. Then that'll give you 4n is less than, and then what's 31 minus 7? Well, that's 24. Go ahead and divide by 4 on both sides of the equation to get n by itself. So that'll cancel out the 4's here. N has to be less than, and then 24 divided by 4 is 6. So n is less than 6. That's our answer. And you can show your answer in a graph like this. Here, they have a number line, and they show from 6, any value that's less than 6 will work. Okay, so that includes 5, 4, 3, 2, 1, 0, and as well as all the negatives, right? So going all the way down to whatever negatives over here. So from 6 on back. Anything less than 6 will work in this inequality. Okay, so here they want you to solve these ones. Okay, so for this one, subtract 7 both sides. So that would be 4d is, now this one has a less than or equal to, but that doesn't really change how we do the algebra. So we'd still just subtract 7 on both sides. That doesn't change anything. 23 minus 7, that's going to be 16. Divide both sides by 4 to get d by itself. So that'll give us that d will have to be less than or equal to 16 divided by 4, which is 4. Now, if you were going to graph this, generally for me, when I'm doing one of these graphs, I just like to show, okay, well, here's 0. 4 will be over here somewhere. I don't need to put everything. I don't have to be like, oh, 1, 2, 3, 4. I don't have to do all that. And then I want values that are less than or equal to 4. So this way. These are less than 4, right? Now, since it has that or equal to, that's gonna, you'd want to color that circle in. So that shows that you're including 4. So if it has the or equal to, that means you're including that value as well. Okay. So if it has the or equal to, fill that in. If it doesn't, so like on the next one, you would not fill that circle in. You would just leave it as an open circle. Okay. So here you would do, for this one, plus 3 both sides. This will give you 5m is greater than negative 15. Divide both sides by 5 to get m by itself. So here m would have to be greater than negative 3. So if I wanted to graph this one, here, maybe I'll put 0 here. Negative 3 is on this side, right? And I want all the values that are greater than negative 3. So these values over here are greater than negative 3. And again, I would leave it as an open circle because it simply has a greater than. It does not have the or equal to. So we'd leave it as an open circle. Okay. For this next one, let's go ahead and distribute this 2. So 2n minus 8 is greater than or equal to negative 6. See if you can finish that one up on your own. Okay. The first step would be to add 8 both sides. Okay, go from there. For number 4, notice I've got w's on both sides of the inequality. We don't like that. We want all of our w's on the same side together. So what I'm going to do is subtract 2w both sides. So that'll give you 3w plus 2 is less than 17. And see if you could solve it from there. Okay. And I want the graphs for these as well. So if you like how we did for these. So if you can do the graphs for those, that'd be great as well. Now, for this next one, I want you to pay close attention to this next one. So here we're going to subtract 5t both sides, right? Because we don't want t's on both sides. We want all of our t's together. Here we're putting it on the left side. Okay, 3t minus 5t, that's negative 2t. We still have a plus 7 over here. And then greater than or equal to 9. Next, we would subtract 7, both sides of the inequality. So on the left side, we've got negative 2t. And on the right side, we have greater than or equal to, and then that's going to be 2. Okay, then you would divide both sides by negative 2. So that'll give you t by itself. Then on the right side, this is negative 1, right? Positive divided by negative is negative. Now, the main thing I want you to notice is that if I divide both sides by a negative, okay? So if you divide both sides by a negative, or if you multiply both sides by a negative, like we do with fractions, right? The inequality sign flips. So this goes from a greater than or equal to a less than or equal to. All right, so that's the one thing I want you to notice. Okay, if you divide both sides by a negative, that's going to flip your inequality. If you divide both sides by a negative, it'll change from a greater than to a less than. Or it might change from a less than to a greater than, right? So every time you divide or multiply both sides by a negative, that's going to flip your inequality. Now, it only counts for multiplying and dividing. Don't worry about adding and subtracting. Don't flip that thing. Don't flip the inequality for adding and subtracting. Only for multiplying and dividing. But since we're dividing by a negative, you flip. If you're dividing by a positive, don't flip it. Only if you're dividing by a negative, then you flip the inequality. So if you're dividing by a negative, this flips from a greater than to a less than. We're going to see that again here. So here, this negative needs to get distributed here. So that's going to be negative 6b. Then the negative times negative 2, that's going to be plus 2. Okay, so basically, if there's a negative outside the parentheses, that changes all their signs. Okay, it's greater than 26. Here we're going to subtract 2 both sides. So then we'll have negative 6b on the left is greater than 24. Then divide both sides by negative 6. Okay, since we're dividing both sides by a negative, then that greater than is going to turn to a less than. So it'll be b is less than, and then negative 4. How much more is there in this? All right, still quite a bit. Okay, I've got a meeting right now, so we'll just have to come back and finish this. Okay, and we're back. Let's go ahead and look at these last bit of problems here. So where we leave off, we're on page 28. Okay. So let's go ahead and read some of these problems, and we'll go through them. When you get a loan from a bank in order to buy a house, the bank will usually require you to make a down payment. In some instances, you need to have a 10% down payment, but other times the lender may require a 20% down payment. If you are buying a house that costs $500,000, a 10% down payment would be, so basically you're just going to find 10% of the $50,000. Now the down payment is what you have to pay ahead of time. Now, most people don't have $500,000 lying around, but they might have a portion of that, a down payment to pay, and then they would have a loan for the rest. So in this case, if you paid a 10% down payment, we would just find 10% of 500,000. So to change that percentage to a decimal, it would be 0.10 times 500,000. And so in this case, if you multiply those, your down payment would be $50,000. So that would be your down payment. A 20% down payment would be double that. So that would be $100,000. So a 20% down payment is $100,000 in this case. Let's keep on moving on here. Let's just move on. I guess we have to do this problem here. As an example, let's look at the Ramirez family. They want to buy a house in Pasadena, California. The lender is requiring them to make a down payment of 15% of the total purchase price of the house. And the Ramirez's have $60,000 saved up to use for a down payment. So the $60,000 is what they can pay as a down payment. And that also represents 15% of the price of the house. So the way we would set that up is like this. 15% is 15 out of 100. Now 15%, that's their down payment, which they have $60,000 for their down payment. And then from there, we can figure out how expensive of a house they can buy. So 15% is $60,000. So what would 100% be? So hopefully you remember from last unit, we can cross multiply and to solve for x. So 15 times x is 15x equals, and then you do 60,000 times 100 is 6, 1, 2, 3, 4 zeros for this, and then 2 more right there. So here we have 6 million so far. Then we divide that by 15 to get x by itself. This will tell you the price of the house that they were able to make a down payment for. So 6 million divided by 15 gives you $400,000. So this is how expensive of a house they could buy. A $400,000 house. Okay. 400,000. Hopefully I didn't mess up somewhere. I don't think so. Here they're saying it's 300,000. No, it should be 400,000, I think. Okay, whatever. All right. So if you can make a 20% down payment, if the total price of the house is 500,000, then you just find 20% of 500,000, and that tells you what their down payment should be. Now we've already done this problem before. 20% of 500,000 is 100,000. And the equation we had to solve was 20% times 500,000. So that's 0.20 times 500,000. So these are like the simplest ones where they give you the percentage and the price of the house. And to find the down payment, you simply multiply the percentage for the down payment times the price of the house. That gives you how much for the down payment. Okay, so these are the same idea. I want you to try these on your own. Okay. Now, what about these ones? This one's saying 15% is the down payment, but we don't know the price of the house, but we do know the down payment. So what we do is we can solve a proportion. So let's go over here to the equation first. So 15% is 15 over 100 equals, and then we would do 45,000 is the 15%, right? 45,000 is the down payment, which is the percentage. So that's 45,000 here. And here we'd have to find the price of the house. Again, cross multiply. So that would be 15x. So 15 times x equals, and then 100 times 45,000 is 4, 5, and then 1, 2, 3, 4, 5 zeros. Divide by 15 both sides to give you x. So 4, 5, 1, 2, 3, 4, 5 zeros divided by 15 gives you a $300,000 house. Okay. This one and this one are the same idea, just different numbers. So give those a try. Now these last ones here, you don't know the percentage of the down payment. So here they give you the price of the home. They also give you the down payment amount, but they don't tell you what percentage that is. So this one's actually pretty simple. To find this, you just take the amount of the down payment divided by the total amount, which in our case is 600,000. You divide those, and that'll give you the percentage for the down payment. Now, you can cancel out 4 of these zeros, right? Because remember, if you have zeros on top and on bottom, you can cancel those at the end of numbers here. So 12 divided by 60, that's 0.2. So as a percentage, so this is 0.2, and change that to a percentage, you move the decimal twice, that's a 20% down payment. Okay. Try these. These are the same, just different numbers. Credit cards. Okay. Blah, blah, blah. All right. So in this one, imagine that you have a $500,000 in purchases on your credit card, and that the bank that issued the credit card is charging you 16% interest. That means that you would owe, and you would take the amount that you owe times the interest rate, and that tells you how much you owe in interest. So in this case, a 16% interest rate, change that to a decimal and multiply those. So that would be $800 in interest. Okay. Now I want to emphasize that credit cards generally don't keep a balance on your credit card. All right. If you use a credit card to buy something, pay it off as soon as you possibly can. As soon as you can. If you could pay the entire thing off right away, do that. Okay. Don't leave a large balance on your credit cards if you can avoid it in any way. You know, just try not to have any balance on your credit cards if you can avoid it. Because this is a very high interest rate that you end up paying. 16% is a very high interest rate. And a lot of credit cards are even higher than that. So if you pay this much per year, then you divide that by 12 and you can figure out how much you pay per month. So in this case, it's $66.67 per month if you divide that, right? So you pay this much per year, which is this much per month. Okay, so let's work on some problems here. First, the amount of interest you pay per year. So what you would do is you take your balance on your credit card times the interest rate, and that'll give you how much you pay in interest per year. And again, just multiply these. You can change these percentages into decimals. I would suggest doing that first. So this would be 0.12, this one 0.10 or 0.1 is fine, and this one 0.20 or 0.2, same thing. Okay, so $10,000, 20% interest rate. Is $2,000 in interest every year. How much is that in a month? So what you do is you take that amount, the amount you pay in the year for interest, divide that by 12, and that tells you how much you pay each month. So in this case, $166.67. I would just round to the nearest cent. So round to the nearest second decimal place. All right, so if you make a monthly payment of $300, the amount paid to the principal. So if you owe this much in interest and you pay them $300, then the amount towards principal is you subtract these. So minus. So in this case, you would have had paid $133.33 towards principal. This basically is saying, okay, you owe $10,000, right? Now this month you made a $300 payment. Now most of that money that you paid on that payment went towards interest, right? But only this amount went towards the principal. So now you basically have a situation where you paid $300, but most of that didn't even help you pay off your debt. Most of that paid towards interest. So only this much actually went towards paying your actual debt. See, this is why having a balance on your credit card is a bad idea, because you'll make a monthly payment, and what ends up happening is a lot of your payment goes towards interest. In this scenario, most of your payment went towards interest. And then the next month, you'll owe a bunch more interest, right? So every month you'll have to pay interest. You could see the amount of interest in 1 year, $2,000, right? So that's not good. Okay. Let me do another one of these with you. So 2,000 times 0.12 to get the amount that you pay towards, or amount of interest in the year. So 2,000 times 0.12 gives me $240 worth of interest. So this is how much interest in the year. Divide that by 12 to figure out how much interest each month. $20 of interest each month. So if we make a $50 payment, 20 of the dollars goes towards interest. The rest, $30, goes towards paying off the principal. Okay. Now, what about if they don't give you the balance here? Well, they gave you the interest, right, is 400. So we know 10% of something gives me 400. So I don't know what this is, but I know whatever that amount is, I'm going to call it X for now. X times 10%, so 0.10, gives you 400. Now, how would I solve for X? So hopefully you can see I would divide by 0.10 both sides. So that would be X equals, and this would be 4,000. And you could always double check because 4,000 times 0.10 should give you 400. And indeed it does. Okay. Then to figure out the monthly payment, again, take the 400 divided by 12, and that tells you how much you pay in interest each month. So in this case, $33.33 paid in interest each month. So if you make a $75 payment, subtract the interest, and that'll tell you how much you've paid towards principal. In this case, $41.67 goes towards principal. Okay, see if you can do the next row on your own. All right, last question. So here we have a challenge question. John just got a Christmas bonus of 15% on his December paycheck. This means that his company added an extra 15% to his normal monthly salary. The paycheck with the added bonus came to a total of $4,600. What is John's normal monthly salary? So this $4,600 is his normal salary plus a 15% bonus, right? So it's his, I'm going to put X as his normal salary. So it's his normal salary plus 15% more, right? So 15% of his normal salary. So it's his normal salary plus an extra 15% to his normal salary. So this would be 4,600 equals, now I can combine these because these are like terms, right? So it's like 1x plus 0.15x. And adding those together, that's 1.15x. To get x by itself, we're going to go ahead and divide by 1.15. And this will give us that x equals, and again, that's his normal salary, 4,600 divided by 1.15, $4,000. So his normal monthly salary is 4,000. Okay, and that's it. That's it for the guided practice. Here's the answer key. Oh, see, I got the last one right. Yeah, if you have any questions, you could always feel free to email me. ttrigg@ofy.org. Okay, well, with that, hope that all made sense, and I'll see you guys next time.